Welcome to the Swayam MOOC course NGOs and Sustainable Development, Unit 1, Module 8, Treatment of Waste. Learning objectives. By the end of this module, you will be able to understand what is waste management, discern the necessity for waste management and treatment, learn about the various waste treatment methods. Waste. Waste can be classified as solid, liquid or gaseous waste. Wastes are produced because of mankind, for example, during extraction of raw materials and processing of raw materials. Each type of waste has different methods of disposal and management. Waste management. Waste management includes processes and action required to manage waste from its inception to its final disposal. This includes collection, transportation, treatment and disposal of waste. It also includes monitoring and regulation of waste management process and waste related laws, technologies and economic mechanisms. Waste management deals with all types of waste including industrial, biological, household, municipal, organic, biomedical and radioactive waste. Electronic waste includes discarded computers, monitors, motherboards, compact discs, CDs, mobile phones, chargers, headphones, television sets, air conditioners and also refrigerators. According to the Global E-Waste Monitor 2017, India generates about 2 million tons of e-waste every year. India ranks 5th among the e-waste producing countries after US, China, Japan and Germany. Waste can pose a threat to human health both directly and indirectly. Directly through handling of waste and indirectly through the consumption of food and water which is contaminated with waste. Objectives of waste management. The waste management objective is to reduce the dangerous effects of such waste both to the environment and to the mankind. A major proportion of waste management deals with solid waste which is created by industrial, commercial and household activity. Waste management is essential for a beautiful urban settlement. However, it is a challenge when there is a huge population moving from the urban and rural areas. It is found that nearly 20 to 50% of municipal budget is being used for waste management. According to the Intergovernmental Panel on Climate Change, that is IPCC, municipal solid waste is expected to reach 3.4 gigatons by 2050. Regulation, laws and sustainable methods of using may restrict the amount of waste getting disposed. Measures of waste management include integrated techno-economic mechanisms of circular economy, effective disposal facilities, optimal sustainable design of products. Principles of waste management. It includes waste hierarchy, life cycle of the product extension, resource efficiency and polluter pays principle. Now let us see what is waste hierarchy. The waste hierarchy is defined as the manner in which we can deal with waste considering the 3R principle, that is reduce, reuse and recycle as shown in the figure. The bottommost layer is the least preferred option and the topmost layer is the most preferred option. The most preferred option is to prevent and the least preferred option is disposal. The top in the hierarchy is prevention, then comes minimization, then reuse to the extent possible, then recycle the product, then try to extract as much energy that is possible from the waste and finally go for disposal of the waste. This classifies the waste management strategies in terms of their desirability for waste minimization. As per the waste hierarchy, the first step is to reduce, reuse and then recycle. Reduce. The aim of waste management is to extract maximum benefits from the waste products and release the end product with maximum value drawn from it. Policies is framed to prevent the generation of waste. This will help to reduce waste to a large extent. Reuse. The preferred action is to seek alternate uses of the waste. Recycle. Recycle includes composting. Wherever possible, it is necessary to go for material recovery and try to retrieve energy from the waste. Finally, the remaining items are disposed in landfills or through incineration. The second principle is extend the life cycle of the product. The life cycle begins with design, then manufacture, distribution, and finally primary use. After its use, the product goes through the waste hierarchy stages of reduce, reuse and recycle. Expansion of the life cycle. What does it mean? The life cycle of the product is increased after the life has ended for the product. For example, we come to the end of the life cycle and then we try to find out how to reuse the product. We try to recycle, repair and do composting. So, when we do all this, we are extending the life of the product and we increase the life of the product so that the number of years extends and the energy and resources are saved. Each stage in the life cycle allows for policy intervention so that the policy is designed for minimum waste and also for the use of the product to be extended. Product life cycle analysis helps to ensure the limited resources are sparingly used and avoid unnecessary generation of waste. The third principle is resource efficiency. What do we mean by resource efficiency? Resource efficiency reflects the understanding that the global economic growth and the development cannot be sustained at the rate at which the present production and consumption level progresses. It is found that mankind is extracting more resources to produce products and is not giving back or regenerating it to the same extent to ensure that the balance is maintained. So, resource efficiency refers to the reduction of the environmental impact from the production and consumption of goods, starting from the raw material extraction to the final use and disposal. Polluter pay principle. Polluter pays principle mandates that the polluting party pays for the damage they have caused to the environment. The polluter pays for the amount of waste for which they are not able to reuse, recycle or recover value from the waste. Waste treatment refers to the activities required to remove the various form of pollutants and other waste present. Waste treatment is essential and in some instances it is mandated by law. Now, let us see some of the waste treatment methods. There are three types of waste treatment methods: A. Solid waste treatment, B. Wastewater treatment from agricultural, industrial and sewage, 3. Radioactive waste treatment. A. Coming to solid waste treatment. Waste treatment technologies under solid waste treatment include 1. Incineration, 2. Landfill, 3. Recycling and 4. For organic waste there is aerobic digestion and B. Composting, that is window composting. In addition to the above, there are certain advanced waste treatment technologies for solid waste treatment. Those include biodrying, gasification, hydrothermal carbonization, commonly known as HTC, hydrothermal liquefaction, which is known as HTL, mechanical biological treatment known as MBT, mechanical heat treatment known as MHT, molten salt oxidization, pyrolysis, UASB digestion, waste autoclave. In addition, there are certain specific technologies for organic waste, namely 1. Bioconversion of biomass to mixed alcohol fuels, in vessel composting, land farming, sewage treatment, tunnel composting. Now, let us see each of these in detail. 1. Incineration. Incineration is a method by which solid organic waste are subjected to combustion and it gets converted to residue and gaseous products. This method is useful for the disposal of both municipal solid waste and solid residue from wastewater treatment. This reduces the volume of solid waste by 80 to 95%. As shown in the figure, the solid waste are sent through the funnel and it gets heated up in the chamber, so that the wastes are removed and flue gas comes out of the chamber. Incineration and other high temperature waste treatment systems are called thermal treatment. Incinerator converts the waste material into heat, gas, steam and ash. Incineration is done both on a small scale by individuals and on a large scale by industry. It is used to dispose solid, liquid and gas waste. It is also used to dispose certain hazardous waste materials such as biological medical wastes. If burning in the incinerator helps to generate heat from waste, it is doubly advantageous since energy is also generated from these wastes. However, incineration method of disposal is not welcomed because it results in substantial quantities of CO2. The presence of organic compounds is of particular concern, such as dioxins, furans, PAH and in some cases heavy metals such as mercury and lead are emitted from these pollutants. Next, coming to the second one, landfill. Examples of landfill sites include dumping, rubbish dump, garbage dump or the dumping ground. Landfill is the oldest form for dumping the waste. Landfill are used for waste management purposes such as temporary storage, consolidation and transfer. It is sometimes used for sorting, treatment and for recycling. Unless they are stabilized, landfill may undergo through soil liquefaction of the ground during an earthquake. Once full, the area over the landfill site may be used for other purposes. In the past, the waste were simply left in piles or thrown into pits. This was called as midden. Next, coming to the third one, recycling. Recycling is a resource recovery process that refers to the collection and reuse of waste materials. This process involves breaking down and reusing the materials that would otherwise be thought of as trash. As shown in the picture, these furnitures are created from reused materials. There are numerous benefits of recycling. With new technologies emerging, it is suggested for more materials to get recycled and make the earth clean. Materials can be recycled, can be collected separately at the source using dedicated bins. The most common products that is recycled include aluminum such as beverage cans, copper such as wires, steel from wood and aerosol cans, old steel furnishings or equipment, rubber tires, polyethylene and PET bottles, glass bottles, jars, paperboard cartons, newspapers, magazines, light paper, corrugated fiberboard boxes are all products which can be recycled and their life can be expanded. Now coming to organic waste, we can go for anaerobic digestion. It is a sequence of processes by which the microorganisms break down into biodegradable material in the absence of oxygen. Anaerobic digestion is widely used as a source of renewable energy. The manure is sent through the inlet. As shown in the picture, biogas is generated in the absence of oxygen through anaerobic digestion. The gases come out from the effluents and is taken out through the outlet, and the waste material comes out at the bottom and can be used for the soil fertilizer. The process is used for industrial or domestic purposes to manage waste or to produce fuels. Much of the fermentation is used industrially to produce food and drink products as well as for home fermentation using anaerobic digestion. Anaerobic digestion occurs naturally in some soils and in lakes and oceanic basin sediments. This is the source of marsh gas methane. The digestion process begins with bacterial hydrolysis and ends finally as methane and carbon dioxide. Anaerobic digestion is used as part of the process to treat biodegradable waste and sewage sludge. Now coming to composting. Compost is a mixture of ingredients used to fertilize and improve the soil. It is obtained when plant and food waste gets decomposed and it is recycled as organic fertilizers. This is found to be rich in plant nutrients, beneficial organisms such as worms and fungal mycelium. Composting requires a mix of both green waste and brown waste. Greens are rich in nitrogen such as leaves, grass and food scraps. Browns are more woody materials that are rich in carbon such as stalks, paper and wood chips. Composting reduces the anaerobic methane emissions and provides for economic and environmental co-benefits. Now let us see the advanced waste management technologies with regard to solid wastes. 1. Biodrying. Biodrying is the process by which biodegradable waste is heated through the initial stages of composting. In biodrying processes, the drying rates are increased by sending in forced air in addition to the biological heat. The heat removes the moisture from the waste. It does not use fossil fuel for heating. Biodrying does not affect the biodegradability of the waste. Biodried waste will still break down in the landfill to produce landfill gas and hence potentially contribute to climate change. Next, coming to gasification. Gasification is a process that converts the biomass or fossil fuel based carbonaceous material into gases, namely nitrogen, carbon monoxide, carbon dioxide and hydrogen. As shown in the picture, the feedstock hopper is the place where the biomass is sent in and it gets dried and it gets combusted in the lower chamber. Because of the combustion, the biochar gets collected in a collection chamber and the exhaust gas comes out through the top. At the same time, a syngas is produced from the combustion chamber which can be used for further purposes. This is achieved by reacting the feedstock at a very high temperature greater than 700 degrees Celsius without combustion by controlling the amount of oxygen and steam. The gas produced from this reaction, called the syngas, can be used for running engines. This gas is flammable because of the presence of hydrogen and carbon monoxide. This gas is considered as a renewable energy if the gasified compounds are obtained from biomass feedstock. Next, coming to hydrothermal carbonization, HTC. It is also called aqueous carbonization at high temperature and pressure. Is a chemical process that converts the organic compounds to structured carbons. The input could be biomass, municipal waste or sewage as shown in the figure. This can be used to make a variety of nanostructured carbons, brown coal substitute, synthetic gas, liquid petroleum precursors and humus. Brown coal formation process is obtained artificially within few hours in this process called coalification, which in normal circumstances will take geological time period of around 50,000 to 5 million years. Next, coming to hydrothermal liquefaction, which is HTL, is a thermal depolymerization process that is used to convert the wet biomass and other macromolecules to crude like oil under moderate temperature and high pressure. The crude like oil has a high energy density with a lower heating value of 33.8 to 36.9 megajoules per kg and 5 to 20 weight percentage of oxygen and renewable chemicals. The reaction uses homogeneous or heterogeneous catalysts in some instances to improve the product quality. Carbon and hydrogen of an organic material such as biomass, peat and low quality coal can be thermochemically converted to hydrophobic compounds. These hydrophobic compounds will have low viscosity and high solubility. Depending on the processing conditions, this crude like oil can be used as a fuel for heavy engines such as marine, rail and also for transportation fuels like diesel, gasoline and for jet fuel. Next, coming to MBT, which is mechanical biological treatment. It is a system to convert the waste using bio-drying facility. It includes sorting with a biological treatment such as composting or anaerobic digestion or bio-drying. MBT is designed to process mixed household waste, commercial waste, industrial waste and sewage sludge. Processing biodegradable waste helps to reduce the contribution of greenhouse gases to global warming. Some of the possible products of this system include renewable fuels such as biogas, recoverable, recyclable materials such as metals, paper, plastics, etc., digestate, which is an organic fertilizer, carbon credits, derived fuel with high calorific value and residual unusable materials which can go to the incineration or to the landfill. Next, coming to MHT, which is mechanical heat treatment, is a waste treatment technology. This technology is also called as autoclaving. MHT also includes sorting and pre-processing. This is allowed for thermal treatment. This includes waste autoclave or a pre-processing stage that produces refuse derived fuel pellet. MHT does not include biological degradation, anaerobic digestion or composting. Next, coming to molten salt oxidation. It is a non-flame thermal process. It destroys all organic materials while retaining the inorganic and hazardous components. It is used as either hazardous waste treatment or energy harvesting, similar to coal and wood gasification process. The molten salt used for oxidation is usually sodium carbonate. The process involved in molten salt oxidation is given in the picture, where the waste which is prepared and sent into the funnel and the vessel heats it and we get the leachable pellets at the bottom. Pollutants, namely sulfur, halogens, phosphorus and similar volatile pollutants, can be oxidized and retained in the melt. Most organic carbon content, namely CO, CO2, H2, H2O gas, leaves in its purest form. The effluent requires a cold trap and a mild aqueous wash. It has been used for safe biological and chemical weapon destruction and for processing waste such as scrap tires. Next, coming to pyrolysis. The pyrolysis is the thermal decomposition of materials at high temperature and inert atmosphere. It involves change in chemical composition and is for the treatment of organic materials. Pyrolysis of organic substances produces volatile products and leaves char, a carbon solid rich residue called carbonization. Pyrolysis can convert biomass into synthetic gas and biochar, waste plastics into usable oil or waste into safely disposable substances. Next, coming to UASB, which is upflow anaerobic sludge blanket digestion. UASB reactor is a form of anaerobic digester that is used for wastewater treatment. As shown in the picture, the diagram indicates that the effluent comes at the bottom, there is sludge present, the sludge granules are present and there are gas bubbles which flows up, and finally the biogas comes out at the top after the treatment. UASB reactor is a methogenic digester that evolved from anaerobic clarigester. Similar to this is the expanded granular sludge bed digester, which is EGSB. UASB uses anaerobic process. Wastewater flows upward through the blanket of granular sludge and is processed by anaerobic microorganisms. The upward flow combined with the settling action of gravity suspends the blanket with the support of flocculants. Sludge granules are formed. Biogas with a high concentration of methane is produced, and this may be used as energy. Waste autoclave. Waste autoclave is a solid waste treatment that uses heat, steam and pressure in the processing of waste. Waste autoclaves process waste either in batches or in continuous flow processes. Saturated steam is pumped into the autoclave at 160 degrees Celsius temperature. The steam pressure is maintained at 6 bar for 45 minutes to cook the waste. The autoclave kills the pathogen and virus in the waste. However, the fibrous products coming out of the autoclave is susceptible to bacteria and fungus, since they are highly rich in starch, cellulose and amino acids. So, the waste need to be sterilized, and a waste autoclave is known as effluent decontamination system. Now, let us see the treatment specific to organic waste. Bioconversion of biomass to mixed alcohol fuels. The bioconversion of biomass to mixed alcohol fuel is carried out using mix-alco process. This process yields a mixed alcohol fuel, and more energy is derived from this process than when compared to obtaining ethanol from the biomass using yeast fermentation. The process involves biological chemical method of conversion of biodegradable waste into useful chemicals such as carboxylic acids, example acetic, propionic, butyric acid; ketones, example acetones, methyl ethyl ketone, diethyl ketone; biofuels, example mix of alcohols such as ethanol, propanol, N-butanol, isopropanol, etc. Next, coming to in-vessel composting. In-vessel composting generally describes a group of methods used for composting within a building, container or vessel. Composting methods may have a metal or a plastic tank or concrete bunkers, wherein the airflow and temperature are controlled, similar to a bioreactor. This method is normally used for municipal scale organic waste processing, including final treatment of sewage biosolids. Evaluation is ongoing with regard to the health risks associated with compost obtained from the sewage biosolids. Offensive odors are caused by putrefaction, anaerobic decomposition of nitrogenous animal and vegetable matter, which is let off as ammonia gas. Land farming. Land farming is a waste treatment process that is done on the upper soil zone. Contaminated soils, sediments or sludges are transported to the land farming sites. They are mixed into the soil surface and then turned over or tilled to aerate the mixture. This is an age-old technique. The more chlorinated or nitrated the compound, the more difficult it is to degrade. Sewage treatment. Sewage treatment is a type of wastewater treatment which aims to remove the contaminants from the sewage to produce effluent that is suitable for reuse or for discharging into the environment. Sewage includes wastewater from all sources such as domestic, industrial, etc. Sewage treatment system range from decentralized system to large centralized systems, which includes a network of pipes and pumps. At the global level, 52% of sewage is treated. High income countries treat around 74% of their sewage, while developing countries treat at an average of just 4.2%. Sewage treatment plant is often referred to as wastewater treatment plant. Aerated static pile composting. Aerated static pile composting or the ASP composting refers to the system that uses a biodegradable organic material without physical manipulation. The composting occurs through controlled composting. With regard to complexity and cost, aerated systems are most commonly used simple systems. Aerated static piles offer process control for rapid biodegradation. Next, coming to the wastewater treatment. Several wastewater treatment systems are available. The list is enormous as shown. 1. Activated sludge system, adsorption system, advanced oxidation process, aerated lagoon, aerobic granular sludge technology, aerobic treatment system, anaerobic clarigestor, anaerobic lagoon, belt filter, biofilters, bioreactors, carbon filtering, clarifier, decanter centrifuge, desalination, distillation, electrocoagulation, hydrocyclone, induced gas flotation, microflotation and several more. The list is enormous. We can get the entire list from the website mentioned below. More details can be obtained from the website. It is beyond the scope of this lecture to cover each of these in detail. However, a few of them have been covered in solid waste management and it will be covered in radioactive waste management. So, now coming to radioactive waste management technologies. The list includes storage based 1. Deep geological repository, dry cask storage, durate, ocean floor disposal, saltcrete, spent fuel pool, spent nuclear fuel shipping cask, synrock, waste isolation pilot plant, deep borehole disposal, vitrification and geomelting. The treatment would include nuclear transmutation, nuclear reprocessing. Now, let us see each of these in detail. Deep geological repository. A deep geological repository is a way of storing hazardous or radioactive waste in a safe location, typically 2000 meters deep. It includes the waste in various forms, packages, sealed and kept in a location wherein there is long term isolation and containment without future maintenance. This will prevent radioactive dangers. A number of such locations are present worldwide. A diagram presented, the schematic diagram presented shows how the radioactive wastes are stored deep into the ground. Canada, for example, in the Great Mine has mercury, cyanide and arsenic waste repositories. In Germany, Harford Neurode Ziltelitz mine has potash. There are several such mines across the globe where the radioactive wastes are stored deep into the ground, ranging around 1000 meters to 2000 meters. Next, coming to dry cask storage. Dry cask storage is a method of storing high level radioactive waste such as spent nuclear fuel. This fuel would have already been cooled in spent fuel pool for a period ranging from 1 to 10 years. Casks are steel cylinders that are either bolted or welded and is completely leak proof. The cylinders are covered by a covering of steel, concrete or other material to avoid the radiation effects from the nuclear waste. Third, Ducrete, which is depleted uranium concrete. Ducrete is a high density depleted uranium concrete used for making casks for storing the radioactive waste. Further, Ducrete presents an environmentally friendly option. It is also cost effective as compared to other materials like steel, lead, etc. Next, coming to ocean floor disposal. Ocean floor disposal is a method of sequestering the radioactive waste in ocean floor, since it is one place that remains undisturbed either geologically or by human activity. There are several methods of depositing in the ocean floor, such as encasking in casks and dropping it in the torpedoes, or depositing in shafts drilled with techniques similar to what we do for oil extraction. However, once placed, it is not possible to recover these wastes. London Convention places prohibition of disposing such radioactive materials at sea, because they are harmful to the marine in case there are leakages. However, this prohibition remained in effect till 2018, after which it was suggested that the subsealed disposal may be reviewed after every 25-year interval. Next, coming to saltcrete. Saltcrete is a mixture of concrete with salt and brine. The purpose is to immobilize the hazardous waste as well as the lower level radioactive waste. Saltcrete is being replaced by saltstone. This is less permeable and leachable. An example of saltcrete is in US, the Rocky Flats Environment Technology Site, famously known as RFETS, near Denver, Colorado. A government investigation during 1989 concluded that many of these materials were being improperly stored and handled. Hence, it was decided that a review has to be done, and Environmental Protection Agency came to the forefront to identify such lists, and they called it as the National Priority List, which has to be cleaned up. Next, coming to spent fuel pools are storage pools or ponds for spent fuel for nuclear reactors. Spent nuclear fuel shipping cask. A nuclear flask is a shipping container that is used to transport the active nuclear fuel between the nuclear power station and the spent fuel reprocessing unit. No physical leakage and radiological shielding has to be ensured. Synrock. Synrock means a synthetic rock, which is a mechanism used for storing radioactive waste. Synrock is made using 3 titanate products minerals, namely hollandite, zirconolite and persocite. Further, there is a small amount of rutile and metal alloy used to make this synrock. It is a bellow-like stainless steel container which can be used to store radioactive waste. Next, coming to waste isolation pilot plant. It is WIPP. It is a deep geological repository and it can store transuranic radioactive waste for 10,000 years. Deep borehole disposal, which is DBD, is a process of disposing radioactive waste in extremely deep boreholes. DBD places waste at much as 5 kilometers beneath the surface. The thickness of the earth acts as a natural geological barrier to safely isolate the radioactive waste from mankind for a long period of time. Vitrification is embedding the material inside a glassy matrix and it is termed as vitrification. When we do vitrification of the radioactive waste, it is found to be safer and most stable form of disposal. Next, coming to nuclear transmutation. Nuclear transmutation is the conversion of one chemical element to another. Again, it is a very good method for disposing of radioactive waste. Nuclear reprocessing is a chemical sequestration of the fission products and unused uranium from the spent nuclear fuel. Reprocessing must be highly controlled and carefully executed. Fuel bundles from nuclear power plants, after having cooled for several years, are used for reprocessing by dissolving in chemical baths. However, the cost is very high in these techniques. Waste treatment involves sorting and treatment. We need to follow the mantra of reduce, reuse and recycle wherever and whenever possible. Treatment of waste is very important because it reduces the effect to both environment and to mankind. Now, let us see a few questions and answers. How can waste be treated? Waste can be treated broadly by chemical, thermal, biological and physical methods. Chemical methods can include ion exchange, precipitation, oxidation, reduction and neutralization. Thermal methods include high temperature incineration, which detoxify the organic waste and destroys them. What is waste management principle? Waste management refers to the practice of collecting, transporting, processing or disposing it, managing and monitoring the various waste materials. It is important to ensure sustainability in all these aspects so that wastes are efficiently managed instead of simply dumping into the landfills. Why is treatment of waste very important? Treatment of waste ensures the effect of these waste on the environment and on mankind is reduced. Directly exposing the waste to the environment leads to health problems ranging from mild medical problems to even death. So, it is very important to treat the waste before they are released to the environment. To summarize, in this module, we have understood what is waste management, discerned the necessity for waste management, learned about the various waste management methods. Thank you.